Hey everyone, so you want Division I college baseball data, right? You want Statcast related type data? Well, I'm going to give it to you today. In this video, I'm going to show you how to acquire the Statcast data of Division I games that were played at a park that had Statcast running at the time. So, I'm going to show you how to acquire all the 23 data so far this season, and then that way you can run the future data for future games. And you should know the future games if you go onto my website, frylytics.com/collegebaseball. Head on over to the Division I tab. Head over to the Savant tab. And then last but not least, you should see all the future games coming up with parks that have Statcast data, so you can go pitch by pitch with that Statcast data, then get the game PKs and pull the play-by-play data to then pull all this raw and cool data. So, we're going to get started simply, and as always, loading in our library. So, library baseball R, that's pretty important. Library tidyverse, so we can do some basic plotting and things like that. So, now that we got those loaded in there, we're just going to get right into it. So, we're going to say, we're going to acquire the game PKs. So, how do you do that? Pretty simple. First, we're going to get the dates. So, we're going to say dates, and we're going to say sequence date. And our first argument is from. So, we know the college baseball season started on February 17th. And then 2, which I will be dating myself here, we'll say 4/17, and we'll say by day. So after you run that, you get an error because you have to coerce it into a date. So don't forget the as date section as well. So then we can see when we run dates, we can see all the dates. So now what we're going to do is, again, acquire the MLB game PKs, MLB, but NCAA related D1 games from this length of date. So simply how you do that is we'll just call it game PKs. We'll say 1 to length dates, go per map function X MLB game PKs dates X, and then the level ID is 22. So run that. Takes a little bit of time, but we're acquiring that data in there. So we can see that we have all these lists of length. So now we'll just say game PKs bind to rows. And now we get the game PKs for the teams. Now we don't have to worry about all of this data. What we really need is just the game PK. So we will just say, adding on to this, we'll just say pull game PK. And so now we have 66 games with a game ID or a game primary key, which is short for PK, to then loop through and pull the play-by-play data of the college level. So what we'll do now is we'll create basically a safe pull. So there's no guarantee that all the games will have Statcast related play-by-play data. So I'm going to create like a wrapper function that will allow this to happen. So I'm going to do per safely, safe PBP, and it's just going to be the MLB PBP function. So that way, in case there's an error, it just goes to the next line of code. It doesn't create an error and then stop our code. So safe PBP, and now we'll just say DAT, which is short for data. We'll say 1 to, not nrow, but 1 to length game PKs. And the same thing per map, function X, safe PBP, and then game PKs X. And if you have the updated progress bar, it'll show you a way to show the progress. So we're going to run this, 66 games, and it says it'll take about 5 minutes. So we'll come back and I'll show you when the code is done what to do next. So now we have all of the data in there. I'll create a data frame, so we'll say D1 Statcast. And we'll take that list of play-by-play data and basically create a giant data frame. But the slight difference between running that safely function and not is you'll need this map result, because what safely does is it puts it into two different arguments, one being a result, which is didn't return an error, and then the other one being error. So we just want the results, and then we want to bind the rows, which is short for just put into one giant data frame. So run that. We see got 22,000 variables, and we see all this data. So what I'm going to do next, now this set of code will be on my GitHub page, so please go over there if you don't want to copy it or go through the video and kind of scan through it. Feel free to pause the video if you want to type it out manually, but it is also on my GitHub page. Just renaming columns and basically aligning it so that way it's in order from first plate appearance to last plate appearance, as well as the column names being a little bit more clear and concise, and things along those ends, just because like with all of these columns it can be a little bit daunting and confusing. So what I'm going to do here is just copy this, and I'll say D1 Statcast, D1 Statcast. So let me scroll down a little bit. Feel free to pause the video if you want to do this manually. Scroll down a little bit more. And a little bit more. Again, feel free if you want to pause it manually. Otherwise, this will be on GitHub. As always, I post the code. So if you want to just copy that code and paste it, you're able to see it. So now we're going to run this. So run it. And now we see 52 variables, but at least this way it's organized and we're removing any like random substitutions or things like that. So you just have the raw data. So you see like pitch type, release speed, spin. So I made it set up to where if you're a student manager at a school or you understand like TrackMan or flight scope or anything of those legs, I set it up to where you can see like the columns kind of match that naming. Feel free to name it whatever you want, but like REL speed is obviously pitch velocity, spin rate, extension, spin direction, things like that. And then we have like description, batter, pitcher, any event, exit speed, launch angle, things like that, bat ball hardness, location, hit coordinates, result event type, RBI, away score, away team, home team, plate location side, plate location height, and then like the accelerations for, mapping out certain pitches. So we can see like West Virginia played the Diamondbacks here. If you want to remove it, great, you can, to where it's just solely college data. But, looking into this, now we can see that it's all organized, all in order, though it's missing. I see it's going from like random days, but it's going in order of game PK. So this game PK, since it's involved with the MLB, is a lower game PK than the actual college games. But we still have kind of, Statcast data. Some might not have raw Statcast data, which is okay. You can remove it, do whatever you want with it, but it gives you this opportunity to look into it. So now we have all the Statcast data. What do we do with it? We can create plots. We can do something simple. Like I said, a plot. We can look at like a basic heat map. We can look at, like a spray chart, things like that. So what we're gonna do here is do like a basic heat map, very basic. Basically taking one of the teams in here and looking at their heat map data. How do we do this? So we can see that we added pitch team and bat team. So I'm just going to do unique D1 Statcast pitch team. Run it, and we see all these different teams. So like you can remove Diamondbacks, the Red Sox. I think that's the only two where a major league team are in there. So if you want to do that, you can say D1 Statcast, D1 Statcast, dplyr filter, pitch team does not, or excuse me, filter exclamation point pitch underscore team in, and then combine Arizona Diamondbacks and Boston Red Sox. So I'm not going to run this, but if you want to remove those teams, you're more than welcome to do so, and that's the code to how to do it. But let's look at trying to think of a team that's been on here enough times where we can see kind of some interesting data. Let's do the TCU Horned Frogs. I feel like they've been on here enough times, so I'll just create a new data frame called TCU, and we'll say D1 Statcast, dplyr filter, pitch team equals TCU Horned Frogs. And so now we have 882 observations of TCU data. So what we're going to do here is create a very, very basic pitch heat map of their overall pitches, or you can split it by count. And then I'll show you like how to do that and basically create charts for yourself. So stay tuned. Okay, now I'm going to show you a very basic just pitch heat map. This is assuming the catcher's view because that's how Baseball Savant displays their docs with plate X and plate Z coordination. So, when we go back up, just want to make sure that we have plate loc side and plate loc height. So, what we're going to do here is just simply use the ggplot. ggplot TCU AS X equals plate location side, Y equals plate location height. And it could be like plate X, plate Z, depending on what you put on it. But this is, again, stemming from the code of GitHub. So we'll do plate location side, plate location height. And then we'll add our little heat map. So we'll say stat underscore density underscore 2D. Use our aesthetic, our fill equals, and then 2 dots on each side. Density, which just alerts R that says, hey, we want a density plot with this fill of this kind. So our GM will be a raster, which is, again, another way of saying we're going to fill our data in, and then we'll say scale, fill, gradient, N, because we're creating our own gradient, and our colors in the British word. Don't forget to spell out with the full colors. So colors, and then we'll say blue and red. And basically, it's basically saying like the higher the heat map is, the more red it's throwing there. And then set our limits. So we'll say x equals combine negative 2.5 to 2.5, and then y equals combine 0 to 6. And then we'll add our geom path, which I forgot to add the k-zone. So we'll just say x, y, and then data equals k-zone, which will come up here before the ggplot, and we'll basically create it out. Now, if you've seen Jim Albert's work, analyzing baseball data with R, he has his own blog post. You've probably seen this before, so we're just going to recreate it. So our top, bottom, in and out k-zone, and then we'll just say k-zone is our data frame, and then x equals combine in k-zone again, out k-zone, in k-zone. And then y, we'll do bottom, top again, bottom again, and end with bottom for a third time. We'll make sure that that's ran. Well, let me run all of those. And now we have our k-zone. So basically what we did is just draw out the strike zone for this heat map, so that way we can be able to see it. And then, knowing me, I like to add a little theme classic, and then add in our labels. So you can say our X label is our horizontal pitch location, and then our Y label is our vertical pitch location. And then our title, I'll say TCU pitch heat map, and our subtitle can be catcher's perspective. Okay, so now run all this, and you can see a beautiful, beautiful TCU pitch heat map from the catcher's perspective. So obviously most to a lot of it were middle. So that's one way of doing it. And then real quick, I'll show you how to like filter down by count, by pitch type. So real quick, we'll run unique TCU $ pitch type. So we see sinker, cutter, fastball, changeup, slider, or curveball. Another way to look at it is TCU pitch name. So let's create a function. So we'll say pitch heat map function. And that way you can look by multiple teams. So we'll say function, TM, which is short for team, and we'll say pitch, and count. So we'll take our data frame, which is D1 Statcast, so we'll just say DF, D1 Statcast, and then we'll say dply our filter, pitch team equals TM, so that's 1, and then we'll say pitch name in pitch, or if you want to do pitch type, it doesn't really matter. We'll just do pitch name because these codes aren't necessarily easier to understand, so we'll just spend the full out pitch name. And the reason why we use in is that allows you to do multiple pitches. So if you want to group those together, like slider, curveball, breaking balls, things like that. And then in front of the dplyr filter, we'll say dplyr mutate count equals, and we'll say paste 0 balls, in quotes, the dash strikes. So then that way we can say count, or I'll shorten this to CNT because it can be tough to filter down the data. So count in CNT. So then we'll have that. We'll copy this data, or copy this code that we just wrote, and change it slightly. So instead of saying TCU, we'll say DF. And then this is where we'll say paste 0. So instead of creating a title, we'll make a custom title where we'll do paste 0 TM, comma, pitch heat map of, and then pitch in, don't forget to add the spaces, and then we'll say in CNT space counts. So that way it's basically saying, hey, here's a heat map of, this team with these pitches and these counts. So now we'll run that. So now it's saved in our environment as a function. So we have to rerun it again. So we'll say pitch heat map function, and we'll keep it as the TCU Horned Frogs. And our pitch, we'll do a combined pitch. So we'll say combine sinker, four seam, fastball, and then cutter. So all fastball types, and we'll do OO count. So we run it, and so it'll get the first name of that. Now there's ways to change it. I'm not going to show it in this video, but we'll say TCU Horned Frogs pitch heat map of sinker and OO counts from the catcher's perspective. So they throw a lot of middle of the plate area. So let's cut it down to actually just being sinker. And so we see that, they're throwing a lot of it middle, maybe away or in to lefties or righties. And that's another thing we could add in our function as well. Again, not going to show it in this video due to time constraints, but it gives you a start of, how to look at some of this data. So thank you so much for watching. If you genuinely enjoyed this content, please don't hesitate. Buy me a coffee. I have a site, just buy me a coffee, $5. Like, if you appreciated this, I appreciate all the work that I've been putting out for you guys. I hope it's genuine. I hope it's great. I hope it's helping you. And if you feel like it's helping you and doing great, chip it back to me and, show your appreciation. It really means a lot, but don't feel like if you have to. Don't feel like if you do. But thank you so much for watching. Have a great day.